Okay, so today's lesson is really just having a conversation to develop number sense. Okay, with percentages, we've already talked about the different models, the pictures we can use to solve percentage problems. There's double number lines, there's tape diagrams. All of those are good visuals, and they're a good place to start because we have background knowledge in how to use them. Realistically, it's not realistic to use those unless one is already drawn for you. Also, those ones work when we're working with pretty numbers, but a lot of times when we're dealing with percentages, they're not pretty numbers. So where do we see percentages a lot, like in everyday life, besides at school? You guys always go to grades because that's what's at the top of your list. But where besides your grades do you see percentages? Naomi? Like on sales? I had a feeling Naomi was going to say sales. She seems like she likes to shop. Okay? Is that true or false? True. Okay? So we see them a lot with sales. Okay? When you're shopping, and most of the time when you go to buy something, like when you pay a certain dollar amount, is it a whole number? No, it's not a pretty number. So tape diagrams, double number lines, they are good tools when we're working with pretty numbers and pretty percentages. But if we needed to find 42% of $28.73, a tape diagram or a double number line wouldn't, it's not that it would be impossible. We'd almost have to count by 1%, breaking it down, which would be a very challenging task. So now we're going to start learning other ways to do these problems. Yes?
No, I have another percent.
Haley, did you have a question?
Yeah. Is the battery percentage on your phone?
It is. The battery percentage on your phone is a percentage. Yes, that's true. So what we're going to do today is I have to help you develop more number sense about percentages. Okay? What is number sense? What is number sense? Harper? It's just making sense of numbers to where when you look at an answer, you can think, hey, that answer makes sense, or that answer doesn't make sense because, and have some background knowledge to back up your ideas, okay? So today we're talking all about benchmark percentages. So flip your notes page to this side where it shows like the table. We're going to start on that side. Okay, definition of a benchmark percentage. I don't know what the actual book definition of a benchmark percentage is, but what I want you to think of is a percentage. Write this down. A percentage you can find mentally. Okay, and I'm assuming the definition had something to do with mental math in the book definition, because the next question says, what is mental math? Sophia, what is mental math?
You're able to solve the problem in your head.
Yeah, math you're able to do in your head. So just talking realistically, what kind of math problems can we do in our head? Usually. Nate?
10%?
Not percentage problems. Like, what math problems can you typically do mentally? Jalen? Okay, so like single digit operations. Most of us all the way up to add, subtract, multiply, divide can do single digit problems mentally, right? What? Yeah, probably up to like factors of 12. Some people up to factors of 13 can do a lot of that mentally. Add, subtract, multiply, divide. Do we all agree with that? Okay. So that's kind of what we focus on. We try and break these into those mental math problems. As we're doing this today, and on your homework, I do make you write out your mental math, but you might write out like 10 divided by 5. Like that's the mental math you would think about in your head. We're just writing it down so you have something to refer back to if you get stuck. Like on this one, I took 10 divided by 5. That's similar to this one, so maybe I would do 20 divided by 5 to get this one. Okay? So the first one, I'm going to just make up a number. So 10% of 80. I want you to write in 80. Now, before we kind of fill out this chart, I'm going to take you back to several weeks ago when before you left class you had to answer a math problem. Does anybody remember that? What kind of math problems did I ask you before I would let you leave? Harper, do you remember?
Like 40% of 28.
I didn't give percentages because we weren't there yet. Sadie? Multiplication, like more specific. What?
6 times like 8.
Nope, I didn't give you.
You gave us ratios.
Not ratios. Livy?
It was some kind of fraction.
It was a fraction. Who can give me an example? Jack?
Like 1/10 of 80.
I would ask you, what is 1/10 of 80? 1/10 of 80. What does of mean in math, Reese? Multiply. So really I was giving you a multiplication problem, but I replaced the time sign with the word of. That is a trick that I want each of you to start doing. When you get to these percentage problems, or fraction problems, decimal problems, if you see a time sign and you think you might have to work it out, try and replace it with the word of. Because if I said what is half of 40, your brain says 20. But if I said what is 1/2 times 40, a lot of you are making it 40 over 1, multiplying top times top, bottom times bottom, reducing, which is still correct, but which way is quicker? Yeah, thinking of the word of, and our brain just kind of fills in the blanks. I'm trying to help you develop that number sense to make these problems faster and quicker and easier. So 1/10 of 80 is this math problem. Why? 1/10 of 80. Why is that what we do here? Cooper?
Because it's 1/10.
Because 1/10 is the same thing as 10%. Okay, that is its common fraction and percentage. We could also do it as 0.1. Same thing. Okay, so with these, we can use those. Does anybody remember what these are called? When I said 1/4 of 24. What is the answer to that one? 6. You don't have to write these anywhere. I'm just going to do some. 1/8 of 16. 2. 1/5 of 20. 4. What are we doing mentally to figure those out? You're taking the whole number and dividing it by the denominator. All of these are unit fractions. If they have a numerator of 1, that's considered a unit fraction, and that trick always works. Okay, that's developing number sense. Because if I split 80 into 10 equal parts and I only had one of them, that's what you're doing. 80 divided by 10 is 8. So for these, we kind of relate this knowledge to percentages. Because do we have some knowledge of fractions as percentages? Yes, so that's exactly what we do here. So 10% of 80. For this one, we're going to write, that's the same thing as 1/10 times 80. 1/10 times 80, which when we see that math problem, what mental math problem can we solve? Stella? 1/10 times 80. What mental math problem could I solve in my head?
Times or divide?
Just the mental math problem to get that answer. To get the answer to that multiplication problem.
1 times 80.
No? Nate?
What?
Okay, so what math problem is that? If I'm trying to figure out how many times 10 goes into 80. 80 divided by 10. So the math problem is 1/10 times 80. But multiplying by 1/10 is the same thing as dividing by 10. That's that reciprocal stuff. KFC, keep, flip, change. Multiplying by 1/10 is the same thing as dividing by 10. So 10% of 80 is 8. I'm going to show you another way to find 10% in just a second. But once we know 10%, so do we all agree that it's pretty easy to find 10% of something? You can use that as a benchmark, meaning you can build off of that. If I know 10% of 80 is 8, how can I easily find 20% of 8? What mental math could I do, Harper? 8 times 2. Why can I do 8 times 2? Because 10% is 8. How do you get from 10% to 20%? Times 2. So you take 8 times 2 to get 16. How could we use that same logic to find 25% of 80? Jack? You could do times 2.5. Can most of us do times 2.5 in our head?
Yes.
No. How could we build off of these two answers to find 25%? Livy?
Add 4 because it's half of 8.
Okay, add 4 to what?
Well, when you to 16.
Okay, so she knows 16 is 20%. Oops. I'm going to kind of write it like that. I'm going to write 20% plus 5%. We all know that 20% plus 5% is 25%, correct? So Livy's saying she sees that 20% is 16. And how did you find 5%, Livy?
I divided the 16.
Because
Yeah, I divided the 8.
Because 10% is equal to 8, so 5% would be 4. So 16 plus 4 is 20. And again, this is number sense. If this is challenging, it's because we're still working on developing that number sense. 10%, if you can find 10%, you can build that up or break it down to about any other percentage. Okay, let me teach you another trick for 10%. I'm just going to write a bunch of them up here on the side. You don't have to write these anywhere unless you want to. I'm just going to write a number and what 10% of it is so you can kind of see the pattern. Okay, we know that 10% of 80 is 8. I'm going to write 10% of dot, oh my goodness, dot, dot, dot. Okay, is 8. 10% of 77, 7.7. 10% of 115, yeah, 11.5. Of 200, it's 20. Of 7.28 is 0.728. So what do you notice? To find 10% of a number, Harper? You move it to the left once because you're finding 10%. The fraction is 1/10. Think about that. 1/10 to the left. All these things you've been learning over the years, they're all coming together. Okay? 1/10 of a number moves it 1 decimal place to the left. 1/10 to the left. If you're multiplying by 10, you move to the right. So if you can find 10% of a number, you can find any percentage. So let's just practice this. I'm going to clear all of those. I'm going to clear everything up there. Clear. Let's say a shirt is $55. And it is 20% off. What is 10% of 55, Max? What is 10% of 55? Who can answer that? 10% of 55. Jude?
5.5.
5.5. So if we're talking money, how much money is that? $5.50 is 10%. So how much would 20% be? $11. Does that mean that if this is the cost of a pair of shoes and they are 20% off, that they only cost me $11? They are $11 off. Remember, every percentage has a dollar amount that goes with it. On our double number line, like if it was 20%, that $11 would be under it, meaning that's the part that you take off. So, and again, I'm just trying to get you to understand these problems because this is where you'll struggle in the harder problems later on. If it's 20% off, how much are you actually paying of the original price? Bryce?
44.
What percentage?
Oh.
Cooper?
10 11.
No. It's almost so easy it's hard. Nolan?
80%.
80%. If it's 20% off, that means you are paying 80%. So this is one where there's two different ways you could figure out this problem. If we found what 20% was, that's 20% off. So then we would have to take 55 minus 11 to get our sale price of $44. What if I took 80% of 55? What should I get?
11.
No, not 11.
Wait, 8, 20. Oh.
So we said 10% is 5.5. So what's 5 times 8? 40. What's 0.5 times 8? 4. What's 40 plus 4?
44.
Why does it make sense that 50 or 80% of 55 is $44?
Oh, wait.
Because we just figured out that 20% off would be $11 off. 55 minus 11 is 44. So either way we'd find that the price is $44. It just depends if you want to do it in 2 steps or in 1 step. I know you guys, I know you would prefer to do it in 1 step, but you have to be able to understand these to be able to make that connection. Okay, clear as mud so far? Good, Cooper, good? Okay, moving on, I'm going to change the number we're working with. Something I should have said before I deleted that. For all of these 3, we could make those connections because these were all the same number. So like over here, how we said we could divide this one by 2 to get to get 5%. It's because the whole that we were working with was all the same whole number. If the whole is different, I can't like take half of it over on this side to compare it to a different one. It's only if it's the same whole number that we're working with. Now on the next set, I'm going to change the whole number. I'm going to change our whole number that we're working with to 90. So next to 33%, change that to 90. And out here, let's give it the better percentage. When they say 33%, they mean 33 1/3%.
So 33 is 33% like not a percent.
It is a percent, but it's not the percent they meant. Because that's 33 hundredths. Why should all of these benchmark percentages, why should most of them look pretty familiar? Chase, why should all of those percentages look familiar on the benchmarks?
That's what we do on the papers.
What papers? Those are our common ones. The common fraction decimal percents, those are your benchmark percentages that if you can memorize those, this is saying it's going to make your life easier. So 33 1/3%, we're going to kind of go back to how we did the first one. If it's 33 1/3% off, what fraction are you actually paying? Jack?
66 2/3.
Correct. So what fraction represents 33 1/3?
33 1/3 over 100.
1/3. So really, if I change this to a multiplication problem, it would be 1/3 times 90. When I see a unit fraction times a whole number, Dane, what mental math can I do? Divide what?
90 divided by 1/3.
Not divided by 1/3. 90 divided by 1/3 is a lot. 270 actually. So I'm trying to get you guys to understand these. Okay, so let me put this into perspective. I have 90 cookies, and I give Addie 1/3 of them. What does that mean I'm doing with my cookies? I'm splitting them into how many equal groups? 3. And Addie gets 1 set of those 3. How many cookies does she get? 30. How'd we do that math? Sadie? 90 divided by 3. if I had 90 cookies and I said Addie gets 1/3 of them, she would get 30 cookies. If I said Addie gets 33 1/3% of them, she would get 30 cookies. If I said Addie gets 0.3 of them, Addie would get 30 cookies. It's all the same thing. 50% of 90. That's the one that makes the most sense to us in our brain most of the time. Carter, how do I find 50% of something mentally? If I said, what's 50% of 10? No. Ethan, how do we find 50% of something? Divided by 2. So this we would do 90 divided by 2, which is what, Ethan? You got that one? 45. Good job. Now, we're going to change 66 to 66 2/3. Now, what fraction is the same as 66 2/3%? Sophia, do you remember that one? The fraction for that one? The other weird one? 5/6. Not 5/6. Stella?
2/3.
2/3. Now, is 2/3, because I mean we could do 2/3 times 90 and we have multiplied fractions before, but let's relate it to the ones we already know. How can we use what we already know to find that one? It's not a unit fraction. Jack?
If we divide it by 6, because 1/3 plus 1/3 plus 2/3, and then.
Okay, so let's not divide it by 6. Let's build off of 1/3. How do we get, if I start with 1/3, how can I get to 2/3? Plus 1/3. So do you guys all agree that 1/3 plus 1/3 is 2/3? What is 1/3 of 90?
30.
30. So I could do 30 plus 30 to get 2/3, or 30 times 2. So that's using benchmark percentages, finding an easy one and then building it up to get a harder one. Okay, for the last ones, I'm going to have to scroll down. Everybody have those ones? Okay, I'm going to scroll down. Let's do 40. Let's do 40 on all these. Let's start with the easiest one. Chase, which one up there is the easiest? 100. What is 100% of 40? 40. Let's go to 150 next. Let's go to 150 next. 150 is what plus what? Harper? 100 plus 50. Let's write that again. I'm trying to get you to walk through this thought process. 100% plus 50% equals 150%. Cooper, what is 100% of 40?
40.
So what is 50% of 40? 20. So what is 150% of? There we go, 60. Livy? Now what?
On the 200% one,
Okay.
you can take 40 plus 40.
Okay, why can we do 40 plus 40?
Because 100 plus 100 is 200.
Yeah, because 100% is 40. Do you guys all agree that's one we can all find quickly? Yes. That's what all of these are supposed to be, are the quick ones. Ones that we don't have to physically sit down and write out a long equation to solve it. Now, 75%. What do we know about 75%, Bryce? What do you know about 75%? It's 3/4. Most of us think that, right? So I'm going to write 3/4. Is 3/4 a unit fraction?
No.
But what unit fraction could I think about? Harper? 1/4. Do we all agree that 3/4 is 1/4 plus 1/4 plus 1/4?
Yes, I agree.
Okay. What is 1/4 of 40? Ethan? 10. How'd you do that?
4 divided by 40.
Okay, so I'm going to show that we're doing 40 divided by 4 is 10. So we have 10 plus 10 plus 10 is 30. Okay, and again, a lot of this is just number sense. We're going to keep talking about this and it will get easier. But also I'm going to teach you math to back up your number sense, because number sense is like common sense. Okay, raise your hand if you know someone who's really, really smart. And you don't have to say names, just think of it in your head that's really, really smart, but like sometimes they say things and you're like, whew, they are not smart. Okay? So it's just like that. Some people can do the math. Okay, and I'm going to be honest, until I started teaching math, I didn't have a whole lot of number sense. I could get the correct answer because I could follow an equation, I could do math, but the numbers never really made sense to me. Okay, I could get the right answers, but when I got the right answers, I didn't know just by looking at it if it made sense. I was just really good at following directions and doing math problems. Okay, flip your paper to the back. We're not done with notes yet. We're going to skip most of the left side, but we're going to add one thing that's going to be important for you to know. Mark out right here. A lot of this we've already covered. I want you to write percent of blank is blank, and then in the blanks write part or percent of whole is part. Percent of whole is part. In percentage problems, they have how many pieces to the problem? What 3 things do we have to be able to find or be given? Nolan? Percent is 1. Livy? Whole is 1. Stella? Part is 1. In every percent problem, they have to give us 2 of those 3 pieces. If they give us 2, we can always find the third. The hardest part is figuring out which pieces they gave me, which one's the easiest to identify. The percent. The part and the whole in a word problem, you have to kind of process it and think about what they're giving you. If it's pretty soon, they'll give us problems that look just like this. They'll say 60% of 70 is what number? So 60% of 70 would be my whole, is what number means I'm looking for the part. So if we can get it to this format, percent of whole is part, it makes it easy to pick out the part and the whole also. In math, what does the word of mean? Multiply. I'm going to go ahead and put that under of. What does the word is mean in math? Sadie? Equal. Okay, and again, hopefully all of this isn't the first time you're hearing it. I've been trying to slowly throw this stuff at you to where it's not so much new information at once. Okay? Let's go over to the examples now. And I'm just going to show you on this one, how long is 50% of 40 minutes? This one's a mental math, and we're going to do it mentally in just a second. But looking, if I know this information right here, if I know that is the percent equation, that is the name of that little thing, percent equation for the rest of your math life, it will be called the percent equation. I know that 40 is my whole. How do I know that? How do I know that in that math problem, because just looking at it, you would almost need more information or a question, but knowing that that's the percent equation, I know that 40 is my whole. Why, Naomi?
Well, first off, because the percent is 50, and the percent sign taken off is because that's the total amount of minutes that...
Okay, so you're using logic, which is fine, but without logic. Livy. It says of blank. Percent of whole, I could write is the part. Am I looking for a part in this problem?
Yes.
Yes. Max, what is 50% of 40? Or what mental math problem could you do to solve it? 40 divided by 2. Let's write our mental math problem. And Max, what is 40 divided by 2? 20. So 20 minutes. How long is 10% of 40? Jalen, what mental math problem could I do if I'm finding 10% of 40? 40 divided by 10 is correct. What is 40 divided by 10? 4. On that one, you could have just moved the decimal point. Yep, because it was 10%. How long is 75% of 40? 75%, is that a unit fraction? Yes. No. Chase, what unit fraction could I think about? So it is 3/4. That's the one I'm trying to get to. But what unit fraction, which means a numerator of 1, can I think about to help me? I'm looking for 3/4. Bryce? 1/4. So I'm just going to put equals 1/4. I'm going to do 1/4 times 3 because that's the same thing. So how can I figure out 1/4 of 40? Sophia, how could I figure out 1/4 of 40? What math problem could I do?
40 divided by 4.
Okay, what is 40 divided by 4? 10. Equals 10. So that's 1/4 of 40. So how could I find 3/4? Nolan?
Multiplied by 3.
Times 3. 10 times 3 is 30. Okay, and again, there's lots of different ways to get to these answers. Now, the next one, they gave us a diagram because these ones are a little bit weirder. 5 is 25% of what number? First thing we're going to do is down on the side somewhere, I'm going to write that different. 5 equals 25% of blank. Which piece am I missing? The part, the whole, or the percent? Jude?
The whole.
The whole. How do you know?
Because it saves $6.
We're up here. Because it says 25% of blank is whole, is part. There's our words. 25% of blank. Percent of blank is part. We're missing the whole. We're going to set this up as like a bar. I'm going to put my percentages on top. So 100 would be down here. Where would 25% go? Or what should I count by? How do I get 25% on there, Livy? Count by 25s, right? Make it into 4 sections. Now, I have to put the 5. We know that 5 is a part because of where it's given in the problem. Where does it go? Jack? Because if I just read this, 5 is 25%. What does is mean? Equals. 5 equals 25%. So if 5 is equal to 25%, I put it right there. How does that now help me? Jack? Now we know we're counting by 5s. How do I find my answer? How do I find my answer? Chase? How do I know it's the one below 100%?
Because it says what is 25% of 20, basically.
Livy?
100% is the whole.
Because I'm looking for the whole, and the whole is always under 20 or under 100%. So I'm just going to write 20. Okay, again, it's mixing lots of different ideas together. That's why I'm having you process this out loud. Okay, next one. Everybody have this before I erase it? I move my finger. Okay, there is a 20% off sale on jackets. If someone saves $6 on a jacket, what was its original cost? Notice on the table they have 20% and 100%. Why do you think they have those two percentages, Livy?
Because, well, one's on top of, you can multiply by 5 to get to 1.
Okay, so she's already kind of figuring out how to solve the problem. She notices that from here to here it's times 5. Okay, that's true. Haley? Okay, so that, and you answered the question I asked. Livy's solving the problem already. I asked why these two numbers. The 20 is there because that's the one that they gave in the problem. Why are they giving me 100%? Jude?
That's what you want to find.
Because that is the whole, which would be the original cost. So this is the box we're trying to fill in. If I can find that, I have my original cost. Okay? What else do I need? Nolan?
The savings for 20%.
Okay, if you save 20%, how much money is that?
$6.
$6. So if you say, so what would be 100%? Go ahead.
Wait, 30.
30, why?
Because 20 times 5 is 100, so 6 times 5 is 30.
Good job. We're trying to develop number sense and percentages.
It's very
It's challenging.
Yes. Do you need me? Okay. Okay.
I didn't see.
Okay. I have one more problem I want you to try because it's the only other kind. So sometimes they give us the percent and the whole. Sometimes they give us the percent and the part. What else could they give us?
Just the percent.
No, the whole and part.
They could give us the whole and the part. So I'm going to show you an example like that because those are almost the easiest, but our brain doesn't always process them. Okay? So at the bottom, I want you to write, they would look like this. 3 is what percent of 5? 3 is what percent of 5? Percent is obviously what we're looking for. So percent of, what's this one representing? Percent of whole, label that one a W, is, so 3 is my part. Where do we, if we're trying to get a percent, where do percents come from? What kinds of numbers can we turn into percents? Haley? Ethan? Or? Fractions or decimals. If I have a part and a whole, can I change a part in a whole into a fraction or a decimal?
Yes.
Which one?
The part.
What is a fraction? What is a fraction? It's a part of a whole. A fraction is part over whole. If you have a part over whole, it's giving you the fraction. The part is 3, the whole is 5. If I need a percentage, how do we change a fraction to a percent? Or this is one we should have up here in our little brains. Nolan?
You could get it to a decimal.
You could. That's the hard way. Don't make life hard.
Just get it to 100.
Get it to 100. How do we get 5 to 100?
Times 20.
Times 20. So what's 30 or 3 times 20? 60. So that would be 60%. So those are the ones people tend to struggle with the most, but really if they give you a part and a whole, they're giving you the fraction. You just then have to convert it to the percent. Okay? And this is going to be challenging tonight because, again, there's a million different ways to get to the same answer, and depending on your number sense, you probably won't work it the same as other people in this class. Okay? You do have homework tonight. Open your books real quick. I want to make sure I give you the right page number. Lesson 13, practice problems. I think it's page 98. Keep going. One more. Yes. Okay. So your homework, keep it open real quick.
What page again?
Page 98, 99. It's lesson 13, practice problems. I want you to try 1 through 5. Okay, I want you to try 1 through 5. I suggest you have your notes handy when you're working through them. Okay? 1 through 5, you don't have to do number 6 on that page.
When's the weekly worksheet due? Thursday?
Thursday, weekly worksheet due Thursday, yes.